Minasan konnichiwa, Edwin desu. Mekishiko gin desu. Yorishiko onegaishimasu. And that's all the Japanese I learned in the plane, but thank you. So I tried to be brief because, you know, things happen like this in production. Who've been there? We deploy really proudly. You say, we have this application as it happens today, but some things happen. Things unpredictable, things happen in the way of not having guardrails, not having governance. And the session of today is it's gonna cover from commit to cloud, how we can push our changes safely. My name is Edwin Moedano. I'm cloud architect at Caylent, a company in the United States. Here are my socials if you want to follow. Okay. There are my socials at Mocha, EDM0CHA. If you want to follow me. Also, I'm a huge fan of Harry Potter. I try to see the movies once a year. Huge fan also of One Piece. I see a lot of anime from here and there on weekends and over the week, and I'm obsessed. Sorry about that. Also a huge fan of Stephen King horror movies, all the horror. I haven't read all the books, but I try to read horror books. I like it. And I'm a huge fan of a band, a British band called Oasis. Back in the 90s were famous, and they reunited last year. And also I'm I'm started my YouTube channel. If someone wants to follow me, Mockups, English, Spanish. If you're learning Spanish, it's a good way to start learning Spanish. But I have a lot of contents that are related to serverless and Gen AI. Let me tell you a story. And, we've been there Friday afternoon, 4 p.m. We want to go to our home or have some drinks with our friends, right? See a movie. And I would say a teammate, for not saying me, we wanted to deploy a Lambda really fast that day. So we needed to set some permissions for the Lambda to write a DynamoDB. Piece of cake, but lazily, I've been lazy and I added a wildcard. Something that will say, okay, it's not a lot of harm, but we tried to move faster that day. Terraform applied the changes because we were using infrastructure as code. But the organization had a policy that I didn't remember at that time. Well, my friend, my colleague, that policy was denying wildcards. And the AM, the service of AWS, accepted that change, and we say, hey, success. But the policy was blocking every request at the runtime. So the Lambda wouldn't have that permission to read or write to the database. Minutes later, the apping went down. My colleague spent all day long trying to find a way of rollback things, but it took 3 hours to realize what was the real problem. At the end of the day, it was an AM change, 6 hours of downtime. And we realized that that policy was blocking. Obviously, we find some ways, workarounds to patch here and there, but the idea is that that problem was preventable if we find a way to have these guardrails before we deliver changes with infrastructure as code, because it's incredible using infrastructure as code, but it has these limitations of maybe applying blindly all these changes. And this is not fine. This was me trying to type as fast as possible while I am seeing the fire in front of my desk. This is not fine. This is not a way to live. So how do we ship changes fast without breaking things? That's the question. There are many answers, but I will try to show you a way that it has been working for me all this time. And by the end of this session, I would like you to, we understand how to structure infrastructure as code projects with clarity and reuse and clear ownership of these repositories, how to design pipelines to reduce risk, and how to introduce validation, checks, guardrails. This is the agenda. We're gonna see some of these topics, like why not just applying, structuring infrastructure as code, patterns, layered validations, policies, and a summary. We'll try to make this fun because we would wait long to be here. So why not just applying? Infrastructure as code gave us a lot of things. Reproducibility. We can have the same infrastructure defined with code and try to reuse it as much as we can because we have already solved the front end, the back end. No, this stack that is always the same. We have versioning control, collaboration between teams. What I like of infrastructure as code is I enable the front-end team to create resources with code, enabling, empower all the team to be responsible and not just one guy, you know, the DevOps guy or the production guy or platform engineer. No, the whole team is responsible for that. And we have different tools. I like to use Terraform, but we have CloudFormation, CDK, Ansible, Pulumi, you name it. We have a lot of options here. And infrastructure as code solve the how we define infrastructure, but not how we ship it. Infrastructure, this changes safely. So what's the common pattern? We have a developer that writes some code. Let's say he's enabling an S3 bucket, and he commits the changes, he or she, and the pipeline triggers maybe some checks. And then we got the plan, and we may do a manual approval. And then we have the Terraform apply, and by the end of the day, we have the infrastructure deployed in AWS or whatever cloud provider you're using. But here's the issues that I see. With development, we don't have linting some of the times. We don't have commit hooks. We don't have clear ownership because it happens to me all the time. Or raise your hand if you have been there. There's a change and then say, okay, I create the PR. And then, to whom I'm gonna send this PR? And then I say, well, someone on the team is gonna see my PR and is gonna be like, hey, proactively taking ownership of that PR, but that doesn't happen. Raise your hand if you've been there. Okay, few of the, okay, well, the idea is ownership. On the other hand, with Terraform and the CI/CD pipeline, the issue is we have no security scanning, you know, compromising credentials or compromising at all some hashes that shouldn't be there in the code, but it happens. We have static credentials. This is a secure space. I want to make it secure space. Can you raise your hands if you're using static credentials to provision infrastructure in your pipelines? Raise your hand. I've been there. Oh, so what other things you're using? Maybe OIDC? Can you raise your hand if you're using your OIDC? Okay, we're in the good. Let's try to move faster with this, but the approvals, we have reviewer manual approvals. We have humans that are not our safety net because sometimes manual approvers tend to be slow, so we tend to auto-approve our own PRs, or let's merge it as soon as possible, right? And in the last point, it's like we have a single environment for the deployment. Most of this time happens that we don't have different environments like gates to start testing our code, our applications. So we don't have dev stages, dev or staging gates. We have no drift detection because the infrastructure that is defined in our repositories is not the same that we have in our cloud providers. So we don't have that after the deployment. So what could go wrong in scale when we are growing these applications? Let's say we started at a POC, but once we go to production with real users, we have fragile pipelines. We have limited validations. And validations, once we start growing, I don't know, for some reason, start to go in less and less and less. And at the end of the day, we have zero validations at all. Our validations are really deprecated because that piece of the code was removed years ago. Unclear ownership, and this is important. We'll talk about this later. Excessive permissions. I know we've been there like trying to move with a wildcard, but our credentials or the way we're pushing our provisioning infrastructure has excessive permissions and no controlled promotions. Sometimes we skip the dev staging prod and we try to make some branches here and there. It's okay, we'll be there. This is a safe space. I'm not judging, I'm just sharing what I've been experiencing in my career. So these are some of the risks if we are not applying this, like unreviewed plan deletes a database. I've been there. We blindly apply a plan and we destroy a database because the database was not configured to prevent the destruction. Luckily, we got some backup of that database, but if for some reason we're commenting or doing some kind of stuff without seeing the plan, we can destroy things really easily. A shared model change without notice. We have different models that, let's say this is the database model, the front-end model, the back-end model, and inside, maybe last week I created some changes. While we tried to deploy, I didn't communicate the changes to my team. So that could lead to unexpected behaviors. And deployed skips staging and goes directly to prod, right? Because it's urgent. This word, it's urgent, harms a lot to the team. So in this way, how we can structure in our infrastructure as code. This is like my recipe. This is what I use all the time. I try to have an infrastructure directory. Inside, I have my models. Whatever models make sense. For example, I have an API gateway, Lambda function, Dynamo table. Then I have my environments, dev, staging, prod. I have a shared, if I need to share infrastructure among services or environments. And then I have my workflows or my pipelines. Also, and this is something I've been trying to promote between all my projects, we should use models as contracts. In the previous slide, I showed you the models in the repository, and that's fine. We can start like that, but once a model starts getting this maturity, we can move or isolate this model into our repository. And with that, we can just point the model to that particular repository that has a specific owner or owners. And for avoiding, like, let's say, changes, unexpected changes for each team, because this model is shared with other teams, we can use the reference of a tag in that repository. So in that way, we have versioning the model, we have tested the model individually, and we can document that model in the repository. And it's no longer a mess of a lot of models here and there. So we have segmentation, isolation, ownership of different models. Environment isolation, and this is important. How I show you is we have the main implementation, but we have a directory for each environment. And this is really good. I don't know, have you ever used Terraform? Raise your hand. Have you ever used workspaces? Sometimes it's a mess using workspaces because explicitly the team doesn't know what is in that workspace. With this approach, you have explicitly the values and the configuration of that environment. So doing that segmentation, not logically, but physically, could help everyone in the team to understand what is going on in that environment. So remote state with locking. This is important. And I know that sometimes when we start these projects with infrastructure as code, we start applying the changes locally. And then we move to the cloud, of course. But the idea is that from day one, we need to have a state lock in our Terraform configuration rather than give it like, hey, let's just start deploying everyone at the same time, no worries. We should have locking. And this is how it looks like in the directory. Like for example, the app directory should have an ownership. And I tend to match a directory with an owner. If, for example, the changes are for the API gateway, the platform team could be the one tagged for those changes. Or the environments prod could be the one tagged for those changes. And your BCS platform could manage that. For example, in GitHub, you can have this code owners file. I will show you an example in a few minutes. But in that way, it's been triggered to tag or assign your PRs to the right team. Patterns. Let's talk about some patterns for safe infrastructure delivery. Running Terraform apply directly without the structure means that you have no visibility, no visibility about the infrastructure, no visibility about who is deploying this stuff. You have no safety net. If you don't check the plan or you don't have a stage where you need to validate the plan, this safety net is gone. No rollback path. Sometimes it's hard. I know we can do a lot of rework or workarounds, but the rollbacks are hard. And if we don't have these guardrails, rollbacks could be something that takes you all your Friday night, and that's it. No promotion control. And that's something that we need to have. These are not like a path. These are gates for you to be secure all the time. And we need patterns. Of course, we need patterns, because if we are building the same things all over again, we're not taking advantage of these tools. So this is the always scenario where we have our static credentials in the CI. So we have the developer that pushed the code, the pipeline is being triggered, and we have our access keys and secrets keys as secrets in our repository. That's a common pattern. And then we can do the merge and Terraform plan and apply. What's the problem with this approach? We have these keys in our pipelines, and potentially those keys can be locked if we don't treat this as secrets. For any reason, may say someone had a bad practicing about logging inside the pipeline, and those credentials are being exposed in the pipeline. So that's not secure, because they never expire. Those credentials never expires unless you go to the console and expire those credentials. Also, you have no traceability, but because it's one user. We're a team of 10 people, and who made that change? You can see in the PR, of course, but if those credentials are shared among all the team, we're in a big trouble, because we don't know who used that credential. Rotation is manual. You need to go to the console and do the rotation of those credentials. If it's leaked, game over. Your account is compromised. You're going to see resources, billing, and it's not a fun day that day. And revoke leads to unexpected behaviors, because let's say that that key was shared with other teams and they're using for one service, and then you're using the same key for a service, for a pipeline, for accessing a database, and if you revoke that, oh man, it's gonna be really fun to, to debug that. This is an approach that's been using OIDC, OpenID connector. Every change is visible before it's applied. The plan is posted in the pull request. We use OIDC to provide identity to the cloud provider instead of using credentials. And going deep, the pipelines proves who the cloud provider is and use a temporal credential. In this way, the pipelines go directly with the OIDC provider to AWS and sign an identity. And AWS, with using AM, identity provider, trusts GitHub, because beforehand we said, trust GitHub and trust this repository and trust this branch in particular. Then AWS sends us the temporal credentials, a scope role, and then we apply the changes and we merge it. And these credentials are created temporarily, so in maybe 10 minutes or more, they're going to be revoked. And the idea is that those credentials are shared in the pipeline, and it's not the same credential at all. It changes all the time. So this is how it looks like with the pattern 2. We have the PR, we have the trigger, we do some linting, formatting, we do the security scanning, policy checks, and we trigger the pipelines. And we use OIDC to apply the changes in dev. And once we are ready, we don't see any errors or issues, we can promote to production. So that is our gates. We're having gates all the time to avoid bad code or bad implementations going directly to production. This is a table. I'm not going to read it a lot because we're almost out of time. But the idea is that we have these gates: linting, formatting, validation, security scanning. And what does those gates helps you? If you have time, you want to take a picture, then read it and make some discussions in your mind about what kind of gates you're applying right now and what gates you're missing in your actual implementations. Oops, did you take the picture, everyone? Yeah, sure, okay. So for drift detection, yeah, I know, infrastructure as code can lead to drift detection. And we were having that discussion yesterday with some amazing speakers that you're gonna listen tomorrow. So your code said one thing, but the cloud says another. Maybe I change it in the console manually, some configurations in the database or in a S3 bucket. And how can I do it? Well, I've been doing this, scheduling a cron job that will trigger a pipeline that will check the plan. If the plan has some changes in any means, I will alert the team and try to do an auto PR with a remediation. So in that way, we are constantly checking for drifting, and we try to be beforehand the drift. So the drift is part of a daily basis, if I could say. Sometimes that happens, but how can we do it? We can put in the pipeline also an agent, and Gen AI agent, checking the drift and if it can create a PR for avoiding drifting. This is how this looks like, the overall 3 patterns that we checked today. The pattern 1 is the plan, review, apply, with a PR-based invisibility, OIDC authentication, and no static credentials. The pattern 2 is multi-gate pipelines with our environments, automated checks, environment progression. And the pattern 3 is drift detection, how to schedule the plan running all the time to alert on drifts. Layered validations and policies and security. This is just an example. I use AWS all the time, but I know that many cloud providers have the same patterns or the same configuration. We have SCPs or security control policies. We can apply these policies to avoid things in the cloud. If you see, we have this in the level of AWS organizations. This is like an ultimate backstop. So we can force the policy to not apply or provision machines or virtual machines that are maybe with a specific type of instance. You know, we don't want bigger instance or small instance. We want just to deploy this kind of instances. We want to deploy this kind of network changes. So with the SCPs, once we try to apply these changes, the policy will deny it. And in your cloud provider, in your pipeline, you're going to see the error. This change is being denied by the policy. We can have, oh, red doesn't look good in this configuration. Sorry about that. We can have the AWS config rules if we need to be in compliance with maybe HIPAA, maybe NIST, maybe we need to be in compliance with a specific policy. So in that way, we can just use this kind of tools to flag our resources inside our AWS account or whatever cloud provider you're using. Also, we can have Sentinel policy as code to check our policies and see if we are not doing something weird, like I did. And we can have some things like LinkedIn, DevSec, checkoff for security and vulnerability scanning. And at the end of the day, we can have the Terraform validate and Flint to do the syntax and checks, you know, just to make sure. And this is applied from bottom to the top. This is the kind of errors you're going, okay, Reddit doesn't look good in this configuration. Again, sorry about that. But this is the kind of errors you're gonna see in the pipeline. Like the Lambda could not be created because you are using a wildcard action because the policy says so. So once you see in the pipeline this kind of errors, you can take actions and avoid releasing that in a Friday night. And this is the policy as code that I was mentioning. You can apply also this in your pipelines. And it's in red again, but say contains resource values policy action wildcard. So this will try to catch any policy I am creating in my code to see if I am trying to deploy the wildcard. If that happens, it will deny it. So let's try to have this demo session. I think we have a couple of minutes, but let's see if that give us time to, well, it's not gonna be like a really big demo because of the time, but I will show you. This is let me do it a little bit bigger, more big, like that. Let me close this thing. Okay, we are ready. So let me do it a little bit. Okay, can you see it from there, everyone? It's visible, the code, the text for you guys? Okay, so I have here my definition of the OpenID connector, and I'm doing the thumb list print about just trusting the hash code for GitHub. And here is my policy for GitHub Actions. And the interesting thing about OIDC is that you can create a role and a policy and just define the actions that your pipeline is able to do. So in that way, you're not having a broad policy and you're just defining, hey, these pipelines usually work only for EC2, Lambdas, and S3. And in the near future, you want to add more permissions, you can do it here or revoke permissions. And this is applied just for that particular role. And for example, here is the SCP I have. for example, this SCP that is applied in the organization I have, it's denying the creation of all the EC2 instance, but it's just letting me allow only the T3 micro. So in that way, if I want to deploy a 2T micro, the policy is gonna stop me there. Okay. Now, let me go to GitHub, and I will show you the repository I was creating for you guys this morning. Here is it. Also, if you want to follow me in GitHub. Okay. So here I have the configuration. Oh, let me do it a little bit big. Is that okay for you to read? Okay. So here I have in my secrets, yeah. No, sorry. Well, it's the same, but per environment. I have this environment defined in my GitHub repository. And let's see what it's development. So right now I don't have any secret, but I have these environment variables. And the beauty of this is that if you see, I have the region and the role of the ARN policy. The ARN role. And I'm just having that, and the account ID is not a secret. It's nothing that make us vulnerable outside. So I can paste the ARN role, and that's it. And let me go to my AWS account. So going to IAM, already created this role. Oh, the gods of the internet is giving me a hard time, but I got you covered. Yeah, we're back. So going to the IAM console, we're gonna look for the role GitHub. And it's this one. So I created this role as any other role in AWS, but I have this trust relationship. Let me do it bigger for you guys. Okay. This is the definition. So I will assume a role with web identity, and I am only trusting my repository. If I want to add more repositories, of course, you can add them as an array of strings. But the beauty of this is that I am federating the access to my account without compromising keys. And if I go to the permissions, this is just the permissions that I've defined to my role. So in that way, we can have our pipelines. We can create the pull requests. Well, this pull request was failing, but we can have like something like this. The Terraform plan, the format failed because I didn't make some good formatting in my files, but the init and the validate works. But the plan, for any reason, fails. Let's see, show the plan. So Terraform and content on error, generating a plan. We can go directly to the pipeline and see why the plan has failed. And and this is the last thing that I want to show you. I didn't get managed to make it work, but here is the code owners file. You can have this definition of the code owners, as I was mentioned you, the directory with whom is gonna be triggered or tagged in your PRs for one reason, to accept the changes because he or she is the owner. And this is really important. So this is the overall strategy. I hope you find it useful. Let me go again to the presentation. And Sorry about that. Okay. What we learned today. I would say that we learned the importance of structure your infrastructure as code with clarity and reuse, ownership, this is important, versioning your models as contracts. This is really important. Try to, if you're not using contracts or you're not isolating your models in different repositories, try to do it one and find owners and make ownership to all your team or part of the team of that piece of code. And also we learn how to use CI/CD patterns that reduce risk and maintaining the speed we have, schedule weekly drifting detection, and run against your production state. For my part, that's it. Thank you a lot. If you have questions, please feel free to do it. But there's an incentive. If you make a question, I will give you a prize. And it's, well, disclaimer, it's a Mexican candy for you to have it. So thank you so much for your time.
Thank you very much.